In this video, we'll try to derive values of trigonometric ratios 0 and 90. So let's just first understand, start from the beginning, and then we'll end up getting values for 0 and 90, especially at least sine, cos and tan. So other ratios, depending on those ratios, so you should be able to substitute these values and find the other values of secant theta or cosecant theta. So let's try. First, let's draw a ray. Let's call this A, and let this be B, and another ray which is actually making certain angle. So all these things we have learnt even from previous standards as basic things. So let's call this C. I'm going to draw a perpendicular here. So main thing is we are trying to come up with a right angle triangle. One of the reason is that I can actually use Pythagoras theorem with this to find the sides. Pythagoras theorem. So in this scenario, I've taken AB as a ray and then AC as another ray which is making an angle of theta. Let me call that angle as theta. So in trigonometric, usually what happens is when we find out angles or sides based on other angles or other sides which are given. So we find out if there are two angles given, third angle or otherwise based on the other ratios. So but we find out by using trigonometric ratios. We call them as trigonometric ratios. So these trigonometric ratios are sine theta, cos theta, tan theta, cot theta, secant theta, cosecant theta. These are the ratios. So here theta for all of them is an angle represented in that triangle. Usually it is an acute angle. If not, if you are considering 90, we'll try to see how we find out the value of 90 here. So before that, what we'll do is we'll try to understand how to write ratios depending on sides of a triangle for these trigonometric ratios. Sine theta, before that let's understand something else. If this is theta, this is the angle I am going to take. Anything opposite to that is actually going to be opposite side. Theta, that will be opposite side. This will be my adjacent side. Because it's a right angle triangle, so this is actually going to be hypotenuse. Sometimes in some textbooks or in some schools, you will also learn this as terminology will be something like this will be perpendicular, this will be base, this will be hypotenuse. So in this scenario, I'm actually going to use opposite and adjacent and hypotenuse. To get sine theta, I need to have the ratio of opposite by hypotenuse. In this scenario, what do you have? Opposite actually represents CB and hypotenuse is AC. Similarly, sine theta will be equals to adjacent divided by hypotenuse. So adjacent in this scenario is AB divided by AC. Tan theta, once you know these two, you can actually write any of this. I have another video on the ratios and also how to find the values of other angles which are 30, 60 and 45. These ones, not the derivations, at least how without memorizing how you can write those values. Watch that video if you are interested. So here we are trying to concentrate on deriving the value of trigonometric ratios for 0 and 90. So tan theta can be written as sine theta by cos theta, sine theta by cos theta. These two, I can just straight away take the value of this and write it here. If this divided by this, what is going to happen? AC gets cancelled, so which is my opposite by adjacent, which is AB, which is opposite by adjacent. Either you can remember this or otherwise remember that particular ratio, how we wrote tan theta equals to. So based on these two, you can write all of them. You don't need to memorize any of this. Now we'll keep this aside and we will try to find out the value for 0. Let's see. If I'm actually going to take, this is for 0 degrees, right? If I'm going to take the same diagram, this is theta and that is B, and there is a perpendicular drawn from that another ray for that angle. So to find 0, that means theta equals to 0. How can I get theta equals to 0? Let's start. If I'm going to assume theta is some 40 or 45, I have to reduce this to 0. I'm going to draw a series of diagram here so that you can understand. Let's try. So this will be AB. Just stay with me. You will get to know exactly what I'm trying to do. So I'm going to reduce that angle. Theta, I have reduced it. That perpendicular still stays and C still stays there itself. So I'll reduce it further. Sorry, I'll reduce it even further. That is C, that is B, and here is theta, there is theta, and this is A. So what is going to happen when I reduce it even further? The last thing, even before it is going past AB. So it's actually AC is actually going to lie on AB. So that means that when I bring that down, theta, bring that down to 0, A will be here and C and B, both of them will coincide each other. So what does that mean? Theta angle is 0 and AC becomes AB. AC equals to AB. Okay, now we said that. Now what's going to happen to CB? CB, when I started reducing theta angle, CB, the height or the length of that side started reducing as well. When theta became 0, AC was lying on AB and length of AC became equals to AB, and CB is nowhere to be seen. So that means the length of CB is actually going to be 0. Length of CB is 0. Now let's try to find out what's going to happen to our ratios. So sin theta, according to this, it is CB by AC. So what does that mean? My sin theta is CB is 0 divided by my AC. It doesn't matter now what value I have for AC or AB. So value of sin theta, or sin in this scenario, sin 0 is actually going to be 0. So sin 0 for the value of theta 0 degrees, it's going to be 0. Similarly, cos theta will be equals to AB by AC. That's based on this. But remember, when we started reducing that theta angle to 0, it was lying on AC, started lying on AB because theta was 0 and AC became equals to AB. So that's what we wrote here. If AC equals to AB, what's going to happen? Cos theta in this scenario 0 AC divided by AC, or otherwise you can substitute AC as AB, one of them. They both get cancelled, that will be 1. So cos 0 is actually going to be 1. So you got two values here. So sin 0 is 0 and cos 0 is 1. Let's understand what happens to 90 degrees. It's just the opposite. Let me draw a series of diagrams here so you can understand what is going to happen. I'm going to take the same diagram. That is B, that is C, that's A, and that's perpendicular. That's my theta angle. Now theta actually has to become 90. So what is going to happen? Let's draw some diagrams here. So theta, I will increase this little bit further. That is C. That will be B. This is actually going to stay 90. This is not going to change, perpendicular. I'm actually increasing theta value so that I can reach at one point theta equals to 90. So let's draw one more diagram. B, that is, sorry, here actually this is supposed to be, this is C, that is C, that is A, right? That is theta. So when suddenly theta becomes 90, that is my theta, theta becomes 90, what is this line? Line is actually going closer to AC. BC is going closer to AC. So that means at when theta becomes 90, BC will lie on AC. So this keeps on going closer, and then when this becomes straight here, this will lie on that. So that means here C will be there and B will touch A and B will be there. So BC will lie on AC. So what happened here? According to this, now we brought it down, AC equals to BC. So we took the diagram, started increasing theta. As we started increasing theta, we kept this 90, the previous one, as is. So that BC line started moving towards left, and then at certain point of time when theta became 90, BC is going to lie on AC. So that means BC will be equals to AC. But something has changed here. What happened to AB? AB, as you can see, AB started reducing. And when theta became 90 and AC became equals to BC, AB became 0. It has become 0. So AB started reducing. A and B are lying on same thing, and then AC is equals to BC, AB becomes 0. Now if I write the same thing, sin theta will be equals to CB by AC, according to this ratio what we have written, CB by AC. So here what is CB? CB and AC, or BC and AC, are same. So I can substitute one of them. That will be 1. And cos theta is equals to what happens? AB by AC. AB by AC. AB by AC. So now AB is 0 from this. 0 by AC. Doesn't matter whatever value we are going to take for AC, that's actually going to be 0. So this is 90, and that is 90. So sin 90 is actually going to be 1, and cos 90 is actually going to be 0. Understand how this line starts moving towards AC, and that perpendicular stays as is, nothing changes in that. That keeps moving. At one point of time they both lie on the same line, and AB vanishes here, and in this case CB vanishes here. So depending on that we have put the values, and we have taken the sides as equal when they started lying on each other. If we substitute those values in our ratios what we have written for these trigonometric ratios, we got sin 0 and cos 0 and sin 90 and cos 90.